So what is an eclipse? Well, an eclipse is when one object passes between a light source and another object and it casts a shadow or it goes into the shadow. So when the moon's shadow hits the earth or the earth's shadow hits the moon, you have an eclipse. An eclipse then occurs when one object in space comes between the sun and a third object and casts a shadow on that object. So there's two types of eclipses that we really look at. We have a solar eclipse and a lunar eclipse. They're the ones that make the biggest impact. Now you can have technically like Mercury or Venus going transient across the face of the sun, but it really doesn't impact the brightness of anything we perceive. You can see it with a telescope, but never again look directly into the sun. This is the phases of a lunar eclipse. This is when the moon at full moon, so it's on the opposite side of the earth from the sun, passes into the earth's shadow. So a lunar eclipse occurs when the moon passes in the earth's shadow. Now what's really interesting when we get into the umbra and penumbra, we look how the light kind of travels around, it kind of has some deflection that happens, and so the moon actually turns kind of a orangey red, kind of like our sunsets, because the longer the light has to travel through our atmosphere, it shifts it towards that red color. So as light travels through the sides of our atmosphere, it casts that red tone. So here is an actual GIF of a lunar eclipse, and it takes quite a while. This isn't something you're just going to ooh and on. It's done in a matter of within an hour. This can take hours for this to occur, to watch the whole thing pass through. A solar eclipse is a much quicker event, but you have to travel farther to see it. We just had a lunar eclipse here a few years ago, and it was beautiful to see. So an eclipse, a lunar eclipse occurs when the full moon is in the Earth's shadow. So it can be seen at night. And what's really interesting is it was one of the first things that helped us prove that the Earth was a sphere, that it was round. Because when we put all the phases of the moon passing through the shadow of the Earth, you actually get this, see the shadow of the Earth. Here is the shadow. When you compile all these pictures together, you can see the curvature of the Earth as it blocks out the sunlight. Again, lunar eclipse is coming out, going into, goes through the shadow, turns kind of red. It's that weird reflected scattered light. So what's happening is, and this is where you're going to want to take either a piece of paper and write this down. There's an assignment that I have a PDF where you can print it if you'd rather have like the lines drawn for you, but if you are creative and want to draw your own lines, you can go ahead and just copy this down. But you will be submitting this. So this is where we're going to actually, I'll have you pause the video in just a minute, and when we're done talking about this, and you're going to need to copy down this diagram. It's on the test. So this would be a great piece of notes to have with you so that you understand what's the umbra, what's the penumbra. Speaking of which, let's take a look at that. So as you look at this sun, you notice the sunlight actually goes out in all different directions. So we have light coming straight on, but we also have sunlight from this side that kind of goes straight that way and goes along here and goes in there along the other side, and you know, all this stuff. So we get these partial shadows, and umbra is really a shadow. Penumbra then is a partial umbra or a partial shadow. So as the moon travels through the penumbra, it's got a little light still hitting, and it's diffused light, but the full shadow right here is the umbra. So the umbra is the full shadow. The penumbra is on either side of it. It's a partial shadow. Actually, it would be a spherical, because of course we're talking three-dimensional, but we're looking at a two-dimensional drawing. It was really interesting. If the moon was out here, that's the point at which that apex occurs. And we'll see that on the other side, because it's a really interesting phenomenon that our solar eclipses occur the way they do. So this is where you should pause the video, draw the sun and the earth. Earth is in the middle, the moon over here. Draw your lines to show the umbra, the full shadow, and the penumbra, the partial shadow. Pause, come back. Okay, you should have drawn your lunar eclipse. Again, you need to have that written down for your test. So here's another view of the lunar eclipse. And we're seeing the sun, and here's the Earth as it travels in its orbital plane, and the moon going around its orbit of the Earth. And so as the moon comes around, it enters the penumbra. Now it's entering the umbra, fully in the umbra, so that's a total lunar eclipse. Anything in here is partial. This is total. And it'll come back out and exit the penumbra and back to just being regular moon. Now remember, this orbital plane, so if the sun is my watch and the tip of my finger is the Earth, most of the time the moon is just so slightly off degrees, but it most of the time hits. But every once in a while it hits just the right, and it travels either into the Earth shadow or in front of the Earth. So in either case of a lunar or a solar eclipse, we're always talking about the sun, the moon, and the Earth, okay? Because that's we're Earth-centric. It's where we're used to being. So here it comes in, you've got the scattering of the light, that prisming effect of the atmosphere, and it just happens to be that that partial scattering makes it all the way back just to where the moon is at that red wavelength. So that's why the lunar eclipse looks slightly red. So, quick review. A lunar eclipse occurs when at a full moon, when the Earth is directly between the moon and the sun. During a lunar eclipse, the Earth shadow falls on the moon, and the Earth shadow also has an umbra and a penumbra. When the moon is completely within the Earth's umbra, you will see a total lunar eclipse. The partial lunar eclipse happens when the moon moves partially into the Earth's umbra. So, if I look here, let's see if we can get this to play.
If you looked at the moon over the course of a few weeks, you'd probably notice that it looks slightly different every day. The change in its shadow...
So, we watched this yesterday. This is that phases going through, and a lunar eclipse can only occur at the full moon.
Is based on where the moon is in its orbit. We call this cycle the phases of the moon, and it occurs roughly once a month. At least twice a year, however, something quite different happens. The moon passes through the shadow cast by the Earth, causing it to look extremely unusual for a short period of time. From the Earth, the moon will appear to darken and turn a deep red before eventually returning to normal. This is called a lunar eclipse. If we were to look at what happens from space during an eclipse, it would go something like this. First, the moon passes through what's called the penumbra, where the sun's light is only partially obscured. This results in only a slight darkening of the moon. As the moon continues along its path, however, it enters what's called the umbra, where all direct light from the sun is blocked. But if the sun is blocked, why does the moon turn red? When light from the sun goes by the side of the Earth, it passes through a long and thick layer of Earth's atmosphere. Shorter wavelengths of sunlight, like blue, are scattered by the atmosphere, so by the time the light has finished its trip to the moon, more of the longer wavelengths, like red, are left over. On the Earth, the same thing happens at sunset, as the ground you stand on gradually passes into night. As the eclipse ends, the moon leaves the umbra, returns to its normal color, and then leaves the penumbra, brightening and resuming its original cycle. Overall, the whole process lasts only from a few minutes to a few hours, so you'll have to be quick if you want to see it. But, as long as you're willing to stay awake, you'll catch the moon as you won't see it too often.
Okay, so if the sound was hard for you to hear, go back and watch that. It's a really good review right before the test of what the umbra and the penumbra is, because remember, all of this information gets shut down, so it's whatever you have written down, like the solar and the lunar eclipse diagrams, or the moon phases. All of that you can use on the test. As any notes that you take, you can use, but my information will be shut down when you test. So, now if we're looking at number one, what position must the moon be in for a solar eclipse to occur? Well, if here's the sunlight, and here is the moon, and here is the Earth, during a solar eclipse, we have to be at new moon, so it has to be at A. The lunar eclipse occurred at the full moon, which was at D. So if you haven't done that, you should go and do that. Here are another place where you could stop the video and pause for a minute and go answer these questions, because we've just gone through these answers. If not, go back and look at the words. You'll find your answers. You're looking at umbra, lunar, solar, and penumbra. So you guess what we're probably talking about is an eclipse, since this is the eclipse notes. This was the super moon lunar eclipse. A supermoon occurs when the moon is at the closest approach as it comes. So it's slightly elliptical orbit. So remember, sometimes it's a little farther away, sometimes it's a little closer. Apogee and perigee. Let's see if this will play. That's the bigger question.
If you look outside on September 27th, 2015,
You missed
you can
it.
catch a glimpse of a very rare event in the
Well,
night
maybe
sky, a supermoon lunar eclipse. To understand what this is, first, take a full moon.
See the ellipse?
Now add the closest approach the
Apogee.
moon makes to the Earth on its own
Perigee.
orbit, which results in it looking up to 14% larger in diameter. That's a supermoon. Now combine this with the lunar eclipse, when the moon passes directly behind the Earth into its shadow, giving it a red tint. Now you have a supermoon lunar eclipse. This is a
So a supermoon is when it's just physically close, and that was about 5 years ago. Well, depending on how long ago you saw this, so 2015. But it was really a beautiful eclipse to see, and just go back and look at pictures of it. So understanding lunar eclipses. Again, any of these that you can't understand, this is where you should stop the video and actually watch it in the notes. But I'm going to go through it just to make sure, hopefully, that you watched it and you're going through the notes. Here we go.
Like clockwork, the full moon appears every month in our sky, a sight so familiar that we often take it for granted. But about twice a year, over the course of a few hours, the full moon sports a decidedly different look.
It's in the
What causes this sudden
penumbra,
change?
then the umbra.
A lunar eclipse occurs when the moon passes through the Earth's shadow, just as a solar eclipse occurs when part of the Earth passes through the moon's shadow. But the moon circles the Earth every month as it cycles through its phases, lining up at both full moon and new moon. So why don't eclipses happen twice a month? The reason is that the moon's orbit around the Earth is tilted relative to the Earth's orbit around the sun. Although
a
the Earth
slight
and the moon
tilt.
always cast long shadows, they rarely shade each other thanks to the moon's orbital tilt. But if that's the case, why do eclipses happen at all? Throughout the year, the moon's orbital tilt remains fixed with respect to the stars, meaning that it changes with respect to the sun. About twice a year, this puts the moon in just the right position to pass through the Earth's shadow, causing a lunar eclipse. As the moon passes into the central part of the Earth's shadow, called the umbra, it darkens dramatically. Once it's entirely within the umbra, the moon appears a dim red due to sunlight scattered through the Earth's atmosphere. In fact, if you watched the eclipse from the surface of the moon, you'd see the sun set behind the entire Earth, bathing you in a warm red glow. Back home, you'll have to stay up late to watch a lunar eclipse, but if you do, you'll see the moon in rare form, and you'll catch a brief glimpse of our own planet's long shadow.
Okay, again, if you couldn't understand that, you should go back and watch it actually in the notes. So we're leaving lunar eclipses. I've gone through it about 8 times, so hopefully you now understand that a lunar eclipse occurs when the moon passes into the shadow of the Earth. So you've got the sun, the Earth, the moon. Now, the order changes with a solar eclipse. We've got the sun, the moon, and the Earth, because the moon shadow is casting on the Earth. So a solar eclipse is when the sun is blacked out. So a solar eclipse occurs when the moon passes between the Earth and the sun, blocking the sunlight from reaching the Earth. The moon's shadow hits the Earth. The darkest part of the shadow is called the umbra, and from any part of the umbra, the moon will completely block the light of the sun. Only people in the umbra see a total solar eclipse. Another part of the shadow is the less dark and larger than the umbra, called the penumbra. From within the penumbra, people will see a partial eclipse because part of the sun will still be visible. What's really interesting is the moon is about 400 times smaller than the sun roughly, but it's about 400 times closer to us than the sun. And so it just so happens that you are living in the one time in Earth's history, because the moon is actually moving farther away from the sun. Or sorry, no, rephrase that. The moon is moving farther away from the Earth at about an inch or so a year. And it just happens to be at that point far enough away where when it passes between the Earth and the sun, we get a total blocking of the sun. And you can see the corona, you can see the surface. So a solar eclipse occurs when a small area of the Earth's surface is in the moon shadow, because compared to the Earth shadow, the moon shadow is much, much smaller. This is as you're going through, so this is the totality where we're seeing the corona, we're seeing the outer atmosphere of the sun. Again, here it is. And right before totality, you get this thing called a diamond ring, because there's just a little teeny tiny spot of light and it looks like a diamond sparkling around a ring, hence the name. And here are two eclipses occurring, and this happens within a pretty brief period of time. And you can see the sun being blocked until it's gone. All we see is the corona, and then the moon coming out, so we see more of the sun again. Here are the phases, kind of looks like a moon phase, doesn't it? Because something's being blocked out, we're seeing less light on that surface. So again, this is where you should stop when I'm done talking and draw and label your solar diagram. So in this case, you'll notice here's the sun, and then the earth, and the moon is in between. And then that umbra and penumbra, that's the same on both of them. It just happens to be whose shadow hits whom. And when the moon shadow hits the earth, it's a solar eclipse because it's blocking out the sun. When it's a lunar eclipse, the earth's shadow is hitting the moon. And so we have that lunar eclipse. So in this case, we have the sun, moon, and earth. Definitely a test question. You want to have these written down. So this only occurs at new moon, okay? This is new moon. Full moon over here is a lunar eclipse. A new moon is a solar eclipse. And the earth shadow, see, it just comes this little teeny tiny point where the umbra happens to hit the earth, and just this little teeny tiny part of the earth is blocked totally from the sun. So you might have to travel, and a lot of our eclipses actually occur over the ocean. And what's funny is when you look at the features of the surface of the planet's shadow, as the moon shadow as it hits the planet, it's this weird squiggly line, kind of like a wave. And because remember, not only is the moon traveling, but the earth is rotating underneath it. So sun, moon, earth, total shadow, umbra, partial shadow, penumbra. This is where you should stop the video, copy this drawing down, and get ready to keep going. Okay, hopefully you're back now and you've drawn that. So what creates a solar eclipse? This is a little bit longer. I would actually prefer at this point if you just stop this. I can and play it yourself. It'll be just a little easier. When it's a minute and a half, it's one thing, but when it's almost 4 minutes, I think you're better off just going into the notes and watching it. All right, so if we take a look at this, I mean, this looks familiar. This is our seasons. This is the equinox and solstices. We learned about this last week. And when both poles have light, we have 12 hours of day and 12 hours of night. This is the September or autumnal equinox, or the fall equinox. We just passed that a couple weeks ago, about a week and a half ago. 2 weeks, I suppose, at this point. And now our days are no longer 12 hours in length. They are much, much less. As we go towards the winter solstice, the December solstice, the official first day of winter, by the way, the equinox in fall is the official first day of fall. And this is the winter solstice. In the northern hemisphere, it is the shortest day of the year, and in the southern hemisphere, it's the longest because you see the South Pole is lit. And once we pass that shortest day, now our days get longer and longer and longer until the spring. The first day of spring is the vernal equinox, otherwise the spring equinox, when we have 12 hours, and from there we get more and more light until we come to the June solstice, or the summer solstice, the longest day of the year and also the first official day of summer. So quick review of that, because it's interesting when you think about what the moon and the sun can do. They all impact each other, including our seasons and our eclipses, but they also create our tides. That pull of the moon and the sun on the earth pulls equally, but not everything responds equally. Think about it. Solid rock on the surface isn't going to pull very hard, but water can. Water is literally impacted by the force of moon's gravity. And if you happen to line up the moon and the sun both in the same directions at a new moon, you get super high tides. Now, if you have a full moon where the moon is on one side of the earth and the sun is on the other side, you have pulling in opposite sides. And also, we're going to get to what those are called. There's these things called spring tides and neap tides. So tides then are the rise and fall of the ocean's water every 12 and a half hours or so. The force of gravity pulls the moon and the earth towards each other. Tides occur mainly because of the difference in how much the moon pulls on different parts of the earth. As the earth rotates, the moon's gravity pulls water towards the point on the earth's surface closest to the moon. The moon pulls least on the side of the earth farthest away. So that would make sense. The side facing the moon is going to have the greatest pull. Tides occur because of differences in the pull of the moon's gravity. In most places, there are 2 high tides a day. So the interesting thing when you think about tides is if we didn't have the moon, we wouldn't have tides. And without tides, we wouldn't have the stirring of the oceans. And without that, it's really hard to get that cold, oxygenated water from the north and the south poles flowing towards the equator. And think about it this way. Hot air expands to fill its space, right? All air does. But the hotter the air is, the farther away from each other it wants to get, and there's more space in between. Well, the same thing happens with water. The warmer it gets, the more space there is in between, and it kind of releases some of that oxygen. We really need that cold, oxygenated water from the poles to well up at the equator where it's being, and by the way, hot and cold, hot always rises to the top. So this is that trick if you ever want to go take a bath and your bath is getting a little cold, actually drain some of the water from the bottom because cold will settle to the bottom and the warmer water on top. So you don't want to overflow your warm water into the overflow. You want to drain the cold stuff out of the bottom, then add your hot water because water will separate out by temperature. The same thing happens in our oceans. And we get that stirring, so that cold oxygenated water upwells at the equator where it's hot and less dense, and it replaces it. But without the tides, we wouldn't have that churning of the oceans, and without that, it's really hard to think of how much life would really not have happened here, because we need that mixing to occur to sustain the plants in the ocean and all that. So it's a big deal that we want that. So tides occur mainly because of the difference in how much the moon pulls. Hang on just one second. Sorry, had to sneeze. So as the earth rotates, the moon's gravity pulls water towards that point on the earth's surface closest to the moon. I know I'm repeating this, but I just want to make sure you're getting it. The moon pulls least on the far side. Okay, again, I know we're repeating, but I need you to think this through. Tides occur because of the difference of the pull in the moon's gravity. In most places, again, there are 2 tides in a day, but some places only have 1, and some that are hard to really see. Here we go. Maybe.
Hey, check out our new test tube app in the iTunes store. Download it, give us a rating, let us know what you think, okay? Okay. Hey there, I'm Josh Clark, and in this brain stuff, I explain to you how the tides work. Have you ever seen somebody buried up to their neck in sand on the beach, and then the tide slowly comes in and they drown, and wondered,
Yeah, don't do
I
that.
wonder how tides work? Well, next time, you'll know, and you can explain it to that person as they wait to die. We need to be very careful here,
Again,
because as
don't do
French
that.
astronomer Francois Arago once said, studying the tides is the tomb of human curiosity, which means it can break your brain, as you'll see. There's a lot of factors involved in creating the tides here on Earth, but the big 3 are the moon, the sun, and the Earth. The gravitational pull of all 3 of those bodies interacting creates the tides. The biggest factor actually is the moon. It exerts about 2.2 times more power on the tides than the sun does. So for once, the moon gets to one-up the sun. It's kind of a big deal to it. Imagine for our purposes the Earth is right here and the moon is directly above it. Now, they exert a gravitational pull on one another, and since on the Earth most things are pinned down, we have shoes, buildings have foundations, stuff stays in place. But the oceans, being literally fluid, actually can be pulled toward the moon, and this is what creates the tide. The moon's here, it's pulling on the ocean at the top of the Earth, creating a high tide on the top. Now on the bottom, another high tide is created because the Earth itself is pulled toward the moon, even though the oceans down here
So it kind of pulls
have
away.
less gravitational pull exerted on them, being farthest away from the moon. So on the top and bottom, you have high tide because of the tidal bulges, and on the sides that are at right angles to the moon, you have low tide because the oceans stretch thin over the surface of the Earth. Pretty crazy, huh? So, like I said, The sun also exerts an influence on the tides, but it's less pronounced than the moon. See, it actually enhances or diminishes the gravitational pull
spring
of the
and neap
moon
tides.
here on Earth. When the sun and the moon are in alignment, the sun enhances the moon's gravitational pull, creating higher tides than normal. They're called spring tides, and they happen on a full moon or a new moon. Now, when the sun and the moon are at right angles to one another, with the Earth right about here, the sun diminishes the gravitational pull of the moon on Earth, creating lower than normal high tides, also called neap tides. These happen on the quarter moon. Because the Earth and the moon are constantly moving around one another, there's a constant movement from high tide to low tide. Twice a day, you get a high tide in most places, usually once every 12 hours and 25 minutes. But this can vary, and some places only see a high tide once every 24 hours. Those are called diurnal tides. So this is a daily occurrence, actually twice daily in most places. But tidal waves, even though they have the word tide in them pretty much, but without the E, they're not related to this gravitational push and pull.
We call
They're
those
usually the
tsunamis
result
now.
of earthquakes. So that's tides. Hopefully we avoided that.
Okay, so that's what we're really getting into. In fact, as some water levels are going, some streets in Florida flood at those higher than normal tides, those spring tides. So here is our spring tide, and that occurs at full moon or new moon. This would be something you might want to write down on your notes. This might be where we want to stop again and fill this out. So spring tides. Here we go. We got new moon, pulls the sun and the moon pulling this way, also pulling the earth towards it, and that little jerk forward also gives us a high tide at the back. And because we're pulling the water in both directions, then that 90 degrees on the sides, those are low tides. So a spring tide occurs at the new moon or the full moon. Again, this is where you should stop the video, and on another sheet of paper, you're not submitting this, but you want it for your quiz, or your test, whatever you want to call it, you should draw this out, because this will help you on that. So spring tides occur at the new and the full moon, and we have the high tide facing the sun and moon on either of these cases. Hopefully you paused and you're coming back. Neap tides are when the sun and the moon and the earth are at right angles to each other. So we have a pull towards the moon at first quarter or third quarter, and then we've got the sun pulling over here. And instead of getting pulled out and elongated, it kind of gets pulled in two different directions. And because of that, they kind of cancel each other out. Not totally, we still have tides. They're just lowest high tides you're going to get. Spring tides are the highest tides you're going to get. Neap tides are the lowest high tides you're going to get. So again, neap tides occur at the first and third quarter moons when we are at right angles, and they kind of cancel each other out. So if you haven't done so, stop the video, draw your spring tides and your neap tides, and get that into your notes. Okay, not a lot of sound on this one, but this is part of the Bay of Fundy, and we're going to watch the tide come in. You ready? Here we go. Maybe. Here comes the tide. Now, this is the only point where those boats can get out. If they're stuck at low tide, they're not going anywhere. It's not like they've got wheels. They need water. High tide came in. Now it's starting to recede, going out. And water's gone, and they are stuck here until the tide comes in again. If you want to watch it again. I still like this one. It's a spring tide, so this is a higher than normal tide. Goes just to the bottom of that decking. And there it goes. And flat out. Bay of Fundy is an interesting shape because of the peninsula of Nova Scotia and like Massachusetts, Maine, that area. It actually gets funneled in, and so you get super high tides, like really crazy high tides. In fact, let's take a look at this one. Maybe. And again, if you can't hear it, stop the video, go watch it, then come back.
It is forever fluctuating, and its shoreline evolves with each passing wave. As the water in the Bay of Fundy ebbs and flows, it creates a phenomenon that occurs nowhere else on the planet. Located on the east coast of Canada, and resting on the coastlines of the provinces of New Brunswick and Nova Scotia, and the American state of Maine, the Bay of Fundy stretches 180 miles long, and the mouth of the bay is 62 miles wide, with its depth ranging between 400 and 700 feet. The tides of the Bay of Fundy are so dramatic that they are considered the highest tides in the world. There are a few reasons why this area of New Brunswick experiences the highest tides. One major reason is its funnel formation. As the gravitational forces of the sun and moon combine to create a continuum of tidal action all over the world, this unique shape of the bay allows for water to flow into a narrow point, leaving it no place to go but up. So how much water actually flows into this area? Well, how about 200 billion tons each day?
Oceanographers calculate that that equals the discharge of every single freshwater river on planet Earth in a day. And the one I like best, if you bulldoze New Brunswick, Nova Scotia, and PEI flat, and you allow the water to accumulate from those two tides, you'd actually be standing thigh deep in water anywhere in maritime Canada. Unbelievable.
It's a lot of water. Okay, so for this next coming test, we've gone through phases of the moon, solar and lunar eclipses, and tides, spring tides and neap tides. All of these things are things that you should have in your notes ready to go for the test when you've got still another week of content to learn before we do that. But those are some big items to have on your test and have those ready to go for some resources. As always, if you've got questions, ask me, jump on Zoom, depending on whichever way we're learning at the time. Have a great day, and I will see you next time.